Today we are going to solve the problem of is subsequence number 392. So we have these two strings and we define ABC, which is a substring. When this ABC, we can find it here in the other string, and it need not to be a continuous substring. Like here we have the let's let's go by alphabets. Like A, we have the A here. B, we have B here. C, so we have the C here. So it need not to be a continuous sub array. So that's why it's called sub sequence. So and if we check if we have AXC here in this example, so we don't because we have A and we don't have X. And the important thing is like the order matters, right? The order matters. Like for example, here, if let's say here, if we have A, B, C, but we have instead of A, we had B, and then instead of B, we had A, so that won't be a substring, right? So let's just look how we are going to go about this. So um, yes, so we have this um, A, B, C, and we have A, H, B, G, D, E. So here we are going to take the two pointer approach. So one pointer would be I, and one pointer would be J. So um, if we compare the position, the value at I and value at J, if they are equal, then we can basically traverse or increase, go to the basically go to the uh, other index, the next index, basically. So what I mean is I'll just show and you'll understand. Like, uh, and we can have a counter. We can have a counter. Like right now, if you can see, we have this A and A, I and J point to A and A. So that means we have found uh, equal alphabets. So counter could be 1 here. And we increase both the counters. So now we have I here and we have A, H, B, G, D, C. So J is here. So as we can see, I is not equal to J. So what we do is uh, the I remains here because we have to find B. Otherwise, we cannot progress in in the left string, right? So A H B G C and J goes to B. So we have found we got another alphabet B. So the counter could be 2 here. Then we have this A, B, C. We increase it. It's C. Now you have to find out C, A, H, B, G, B, C. J is here. So C is not equal to G. So we don't have to increase this, but we have to increase the J pointer. B, C, the J comes to B, but still hasn't found C. So we go to A, B, C, then A, H, B, G, D, C. So we have found C. So the counter is 3. And of course, uh, we we are at the end of the we are at the end of the array, or and C is equal to 3. So that means we found alphabets, all the three alphabets in this. So that means this is true, right? So this is a subsequence. ABC is a subsequence. And one more observation is like we don't need the the counter variable, because by the virtue of like if I is here, I is at C, so that means uh, and if we so I here means it is at the its value is 2, but at the end after the loop is over, I would be 3. So if I equal to length, right, length of the left substring, right, so it should be like if I equal to length of the left one, let's say this is S, length of S, then that means we found all the three. We did found all the three alphabets, right? So let's just do it. Uh, so here is the code. I can remove this and we can do it again. So we have this I and J that can be initialized to 0. Then we can have length of I equal to, length of S equal to length of S, and length of E equal to length of C. So, while I is less than length of S and J is less than length of E, then this is the breakpoint basically. We have to go like we cannot go beyond the length of the strings. So so if, um, if s of I equal to e of j, right? If that is the case, then we can do I plus equal to 1, because remember the left string, if we found something, then only we increment it to the next index. Otherwise, in any case, the right string, needs to be incremented, right? And return um, I equal to length of its So if I is equal to length of S, that means length of the left of the string, which is this. So if uh, this, so if it is 3, then that means that we have found out all the three um, characters in this string, right? Uh, length of the, so yeah, that's the correct solution. Yeah, that's it. Let me know if you have any questions or comments. Thank you.